Hi class, welcome again to another session on digital principles and system design. We are going to continue learning Karnaugh map now, but this time we are going to learn how to deal with four variable Karnaugh map. So the prerequisite for learning this is that you should be knowing how to simplify 2 and 3 variable Karnaugh map. You should be familiar with sum of products and products of sum. Okay, so let's crack on. So, like I said, if n is the number of variables, 2 raised to n would be the number of minterms or number of cells in a K-map. So since it's a 4-variable K-map, we'll have 16 cells. So the variable, for example, can be w, x, y, and z. We'll also have a, b, c, and d. Any foreign alphabets that you fancy. Okay? It's not necessary that you have to have w, x, y, and z. It can be a, b, c, and d as well. Right? So, if you observe how the bits are arranged in the y-x-axis, it's 0, 0, 0, 1, 1, 1, and 1, 0. So, vertically downwards, it's 0, 0, 0, 1, 1, 1, and 1, 0. The same rule applies here. One bit, when there's, for every cell, there should be only one bit that is changing. Okay, so if it is in the horizontal direction, either y should change once or z should change once. We cannot have both y and z changing simultaneously because that's going to make our life difficult, right? That are adjacent to it. Now, why this funny ordering? Like I said, we can apply unity theorem if only one variable changes. For example, the one in the red is x dash y dash z and x dash y z. So we can see that x dash and z are common on both and only y is changing from y dash to y. So if we take x dash and z outside, we get y dash plus y, which is 1. So this is equal to x dash z. So, adjacency includes wrapping around from left and the right side. So, if we see the ones in the blue, right, x dash y dash z plus x y dash z, z dash plus x dash y z dash plus x y z dash. So, we can see that z dash is common for all. So, if we take z dash out of the expression, we get x dash y dash plus x y dash plus x dash y plus xy. Again, first two terms, y dash is common, so you can apply x dash plus x there. The last two terms, y is common, so you can again apply x dash x. Ultimately, the equation totally reduces to just z dash. That's why we have this funny ordering. Right, so there are certain rules that need to be followed, that grouping of minterms should be rectangular or square and should have a size in the power of 2. Right, it can be 1, 2, 4, 8, and 16. You cannot have 6 or 4 or funny shape like the Z one in the pink or the L shape or the diagonal ones. These are no-no for simplification of the K-map. You can't use them. Okay, and grouping should be, for example, the blue one, 6 is not allowed, so it could be 4 and 2. So looping process, like I said, you can wrap around the edges and loop. Okay, so it can be grouping of two. For example, the first figure A, you have 1 and 1 at this term. So this simplifies to B dash C and so on. So looping is something that you cannot, like, you can't just use any terms to loop things together. You have to follow the rules. Now, example of looping pairs of adjacent ones. So adjacent ones are the ones that are next. So the first one is BC dash because there are just two. So there's a horizontal one. Now the fourth one, the D, has got a horizontal one and then two are wrapped around the edges. The C has got two ones in the corner, so they are the wraparound edges and you can group them together. So if there are four ones, so it can either be a vertical four, a horizontal four, or a square. It can be two edges that are grouped together, or it can be all the four corners of your square like in figure E. So these are another way of looping the one. So these are looping in four. Looping in eight, so you can be, you can use rectangular looping, or you can use looping of the edges. Anything vertical or horizontal looping is also possible. So the simplification process is pretty much straightforward. You can construct a K-map like how many variables. If it's four variables, then draw a square with 16 mini squares inside it. If it's an three variable, draw a rectangle with 8 squares inside it, and then replace it with ones and zeros according to the truth table. If you're using min terms, then the position of the min term that is available from your truth table should be replaced by 1. Now, looping the isolated ones which are not adjacent to any other ones. So single ones, just separate them together. Then go to double looping, and then keep on, grouping all the ones together. Generate the find out the simplified terms for each and every group and over them together ultimately to get your function. So let us see. Sorry, the terms that are unchanged will consist of your min term. Therefore, for loop 6, 7, 10, 11, your term would be B, D, because B and D are unchanged, irrespective of A changes from A dash to A, C changes from C dash to C, but B and D do not change. Therefore, ORing all the three product terms, you get the expression X, which is your output for this particular K-map. See another example. Here, you've got a few ones, right? 3 and 7 are grouped together. 5, 6, 7, 8 are grouped together. 5, 6, 9, and 10 are also grouped together. So if we see 5, 6, 7, 8 first, it's just straightforward. C and D are continuously changing, right? A and B remain constant. Sorry, A dash B is the only one that is not changing. So that is my first term. If you see the 5, 6, 9, 10 one, vertically B remains unchanged, horizontally my C dash remains unchanged. So that term becomes B C dash, the second one. Now grouping 3 and 7 together, or min term 3 and min term 7 together, you can see that CD is not changing because that's the column. A dash is not changing. However, B dash is changing from B dash to B. Therefore, my term becomes A dash C D. I OR them or add them together to get my expression. Now this is a funny one, right? So you've got a few ones. All of them, they are individually grouped. So you don't have to actually group 6, 7, 10 and 11 together, right? So each one of them, you just write the individual expressions and you get the answer. So if you choose to group 6, 7, 11 and 10, you end up with 4 overlapping groups of 2, or you end up with 4 single ones. Neither are acceptable, because if you end up with too many overlapping groups, then the chances is that your min terms might repeat and you'd need further simplification. Therefore, this is the best way to do it. Now, there are chances. Now, that was, now consider this K-map, right? So, figure A is one way of grouping them and figure B is another way of grouping them. Both are giving equally good solution. Both are giving unique solution. So, you can have more than one solution for a particular K-map sometimes. Alright.